Alright. Let me just get the live stream on the playlist so people can actually find it. Okay. Cool. All right, well, you three, thank you for showing up. Everybody else is out. Well, they say they're out to stand in solidarity with the students doing a walkout today. But we all know the truth, that everybody just doesn't want to come to class, right? Which is fine. I mean, I don't care either way. Hell, less people in class, the more people watching the stream, less I get COVID. All of us get COVID, so great. But yeah, for anybody who came today, thanks for showing up and wanting to be here. Last time we just covered Hume, right? We covered Hume's problem of induction, the basic problem. Can they state the basic problem? Or I guess the basic question that Hume raises?
It was basically like how, or like why do we like assume that like predictions based off of past experiences are like a reliable source of like or like sound and like arguments.
Yeah, like they're reliable guides to truth.
Right,
something like that, yeah. It's hard to talk about it precisely, because as soon as you start talking about it, you start assuming that, well, you've got strength and cogency, and it's like, well, but that's just asking the same question again, right?
Exactly.
So we've got, essentially, Hume doesn't specifically say this, but what's implied is that we've got all these different forms of inductive reasoning, right? Do you remember what they were? What are the different types of inductive reasoning? I think I listed 3.
There was one of like future
prediction, and you had something?
Past prediction.
Past prediction.
And present prediction.
Present prediction. Okay. So we've got this sort of thing. We've got where we move from, let's just say, past data or past beliefs, and we're trying to infer from that a prediction of the future. Right? That's probabilistic, that's inductive. Well, then we've also got over here, where's my eraser? We've also got over here, we're starting from present data that we find, and we're trying to go up to what? We're starting from the present, we're trying to predict what?
the future or the past.
Yeah, the past. We're trying to do what I call a historical reconstruction. So present data, we try to predict how the past was, right? Or we try to give a causal history. Does anybody know the word for causal history? If you study medicine, if you ever do anything in medical or medical science or anything related to that, you'll eventually study something called etiology. Etiology is literally just this causal history of what in medicine, what's the chain of how, like the vector of how a disease spreads, right? What's the causal mechanisms of this disease? Okay, the other thing we had, it's not really predictions of the past or the future, but we move from, let's just say, observe the data, right? Like my car doesn't start, that's observed. And then we try to predict or reconstruct exactly like the causes present now. And again, there's not really like a tight division between these things. Any particular theory might be a mix of past, present, and future. The point is that all of these different types, whether you're moving from past data to a future prediction, present data to a past prediction, observed data to, let's just actually say, observed data to unobservable truth, or you're just making a straight up argument where you have evidence 1, evidence 2, and then from that evidence you are inferring with probability some conclusion, right? All of these types of arguing rely on what?
Induction.
Inductive reasoning. So this is pretty much, I think, unless I'm leaving something out, this is pretty much all types of human inductive reasoning. And if you see, if we couldn't do any of this, that'd be a major problem, right? So Hume's problem says that all of these types of inductive reasoning are problematic. They're iffy. Does anybody need this up on the board? You good? Okay. Okay, so why does he say they're iffy? Do you remember?
If evidence can't, how can evidence justify a conclusion if it can't guarantee it?
Right. So Hume basically is just asking a question. It's not so much that he's attacking induction, it's that he's asking, how the heck does this work? So he's asking essentially, how does, or what does it mean for some data, past, present, or future, or whatever, unobserved, observed, for some data to make some, let's say H for hypothesis probable without guaranteeing or proving it. Right, and that is essentially just a question of like, what is probability? How does this stuff work? And we saw last time, I believe I gave the argument, the sun has always risen, or something like that, doesn't matter how you put it. And then we have a conclusion, sun will rise tomorrow. I don't know why I always misspell tomorrow with 2 M's, but whatever. Okay. Do we look at solutions of maybe how we could fill this gap in? Do you remember if we did?
Yeah,
Yeah.
We talked about like the principle of like regularity.
Okay, cool. So I think that's all we talked about, right? Principle of regularity. So essentially, Hume's question is, another way of asking what is probability, how do probabilistic or inductive arguments work, is how do we get from this to this? Can you explain to me how this somehow justifies this? If you could fill in this gap with some sort of principle or some premise that I would find plausible that would bridge the gap between past data, future prediction, right? That's what we want. The principle of regularity, do you remember what that is?
Yeah, it was basically that like if we go based off of what like normally happens and how like the sun like rises every day, then we can expect, unless something irregular were to happen, that like the regular continues to happen.
Okay, cool. So let's call this the principle of regularity, PR, right? What we try to do here is that, and if you read that Peter Lipton chapter, Lipton calls it the more of the same principle. It's basically saying that the future will resemble or be continuous with the past. Now, for one, it's just not true, unless we really nuance it, right? Like, we know the future changes, things change. At one point in time, human beings didn't exist at all. Now we do. That's a pretty big change, right? So we know this is just false. But even if something like it were true, what was the problem with the principle of regularity?
There are irregularities.
there are regularities, yeah, so it's probably not true. But what is the problem with saying, well, the future is always going to be like how the past was? Now we know it's not true, but it's circular in a way, right? Because it's still relying on induction. This is still a prediction, right? So it's still an inductive prediction. Now, how would we know that the future will always resemble the past, or the past will always resemble the future? Well, if we did know it, it would be because in the past, the future and the past have always resembled each other. So if we're going to say this is true for the future, that still is a prediction that this will be true in the future, right? So it's still just an inductive prediction based on past experience at its best. It's probably just straight up false, but even if it was true, it would still be circular. So our first attempt to give an inductive principle, the principle of regularity, fails because it actually just makes the problem worse. It just gives us another type of inductive premise that we have to then justify. Does that make sense? Okay. The other type of premise, and this one might be more clear if I modify the argument. Let's say my argument or my prediction now becomes every time I have hit ball A with ball B, B has moved forward. So imagine we have two billiard balls, as Hume's example, if you remember from the reading. We have billiard ball A, we have billiard ball B. We are freaks and weirdos, and so we have been sitting at a pool table and just smacking billiard balls into each other over and over again for the last 10 years. We just keep doing the same thing for some reason. We hit A into B, and then every time we do that, B moves forward, right? What would you call this? Causality, or cause and effect relationship, right? So A causes B to move forward. And we've seen every time we've done that in the past, A causes B to move forward. So I can conclude now, what prediction can I make?
That whatever caused it in the past will always, will cause it in the future.
Right. We can say my prediction is if I take that same cause from the past, I move A and hit it into B. So if A hits B, then B will move. Right? Raise your hand if you think that's a fine argument. Yeah. The question is, it's still got that gap, right? Just because we talk about causality and things causing things in the past, there's no necessary guarantee that it's going to cause the same things in the future, right? So Hume has two problems here. The first one, he says, look, if we want to invoke some sort of causal principle, maybe we could say something like causal principle 1. Maybe causal principle 1 could be if A causes B, well, let's not use A and B, it's a bit more generic. If X causes B, no, screw me. If X causes Y, then X will always cause Y. Right, and you can narrow that down and make it more sophisticated. Obviously, there's going to be things like, well, yeah, but just because the billiard ball hits, maybe there's another billiard ball blocking it, right? So it's not that every time A hits B, B's going to move. It's that every time A hits B in the same conditions where there's nothing blocking B or stopping B, B's going to move. And essentially it boils down to, look, if X causes Y, then X is always going to cause Y in the same conditions, right? So we try to fill in this argument with this, I guess we'd call it the causal regularity principle. And now we're not just talking about, well, the past and the present are always going to look a lot alike. We're talking about the causal mechanisms that were happening in the past are going to continue into the future. So every time I hit ball A with ball B, B has moved forward. Or we could also say A causes B to move forward, right? Causal regularity principle. If X causes Y, then X will always cause Y. Now that seems like a good deductive argument, right? Well, because A has always caused B to move forward, then A is always in the future going to cause B to move forward, right? So the billiard ball prediction, if I were to hit A into B, or the next time I hit A into B, B will move forward. Seems like a strong argument that I just filled in the gaps, right? What's the problem with it?
It's still a prediction.
It's still a prediction. It still relies on, because this always happens in the past, it's always going to happen in the future. So even when we start talking about causality, we're going to have the same problem of induction arise. It doesn't fix anything. Something like this is probably true, but the question is, we're not asking if the laws of physics are true. We're asking, how can we know the laws of physics will always be true? Maybe they've been true in the past. Will they continue to hold in the future? And that's what Hume wants to know. Does that make sense? So causal regularity principle is bad. It doesn't solve the problem because it's still circular. It relies on an inductive prediction. All right, there's a second problem Hume has. Does anybody remember what it is? There's a second problem with causality itself. Here's the problem. What does it mean for A to cause B? What does it mean for A to cause B? Try to just explain it to me. Like, if I get a billiard ball and throw it at his head, and it hits him, and he goes unconscious, what does it mean that my action caused that?
I don't know how, like, put it in words, but, like, I feel like it's just, like, something happens, like, something that happened, like, something happened before to make that happen.
Okay, so something A happens, and then B followed,
Yeah.
right? Yeah, that's exactly what I'm looking for. It's good.
Okay.
So, what would you call that? Does anybody know? If A and B happen together a lot, what's that called?
Correlation.
Correlation. Does correlation equal causation? No. 2 plus 2 equals 4 is true every single day I wake up. Every single day I wake up and I'm still a boy. Right? Maybe one day it will change, but so far it's been tightly correlated. That doesn't mean math is causing me to retain my gender identity, right? So, but the problem is, can anybody give a better definition of causality than that? A happens, and then B happens.
It's like the reason, like, never mind.
Okay, we could say A is the reason B happens. That's actually really good. That's going back to Leibniz like last time, right? The principle of sufficient reason. A is the reason B happens. Another way to say that might be A makes B happen. But in each of these cases, we're not actually defining causality. You're just replacing it with different words and phrases, right? You're just saying, well, A makes B happen. A is the reason B happens. How is that any more illuminating? How does that teach me what causality is in any way more than just, well, A caused B to happen, right? Do you see the problem? So Hume's thing is that Hume is an empiricist, erase this and spell that. Hume is an empiricist, and which means, for the most part, knowledge comes from sense experience, right? Experience of the five senses of the physical material world. All right, look around in the physical material world, and what do you find? Well, you find lots of things correlated really tightly. Every time I move the billiard ball into B, B moves. Every time I throw a billiard ball at your head really hard, you die or go unconscious, right? You have these correlations, but if you actually observe the physical world, you never see or observe causality, the relationship, the reason why, or what it means for A makes B happen. So, if Hume is an empiricist and says all knowledge comes from sense experience, and knowledge of what causality is doesn't come from sense experience, then what's that tell you? If all knowledge comes from sense experience, and sense experience doesn't really give us knowledge of causality, then can we have knowledge of causality? Seems like we've got a problem. So, the point here is that, okay, one, causal regularity principles, they're going to be circular. They're not going to solve the problem because they're still just predictions. A has always caused B in the past, so A will cause B in the future, right? So it's still just inductive. We still have to solve that. The second thing is, we don't even know what the hell causality is or what it means. Our only concepts are just very tight correlations. So that even if we find a causal principle that works, we're still going to have the other problem of discovering what causality means itself. So it's just super problematic, the causal regularity principle. Does that make sense? Some people that are super into physics or atomic physics might say, well, okay, you can't understand what causality is at this level. You have to talk about atoms and particles and how they interact with each other, right? Well, let's just look at like an electron, right? Or an atom with a positive charge. An atom with a positive charge is going to push away atoms with a negative charge, right? But they're just the same as billiard balls. How do they push away? We see when this atom with a positive charge gets near an atom with a negative charge, or whatever it is, then the atom with a negative charge moves away. But we never actually, we can look all we want through an electron microscope, we'll never actually see or observe causality. We'll just see tight correlations still. So the problem goes all the way down to like the fundamental levels of physics too. Does that make sense? Talking about positive and negative charges, like a positive charge is defined as having the power to cause a negatively charged atom to go away. So that doesn't even tell you what it is, right? Okay, so both of our attempts, we have tried to give two different principles of regularity. We've given the past resembles the future principle of regularity, and then we've given, a general kind of causal principle, causal regularity principle. Both have not worked to solve the problem. What else can we do? We've got causal regularity. We've got, let's just say resemblance principle. Does anybody have other ideas? There's got to be some way to save it, right? To save induction and make it work, or else we're screwed. Here's one suggestion. hasn't induction always been like, it's worked really well for us so far, right? So isn't there something to be said that, well, if it's worked really well for us so far, then that's a good indicator that it's true, right? Or that's reliable, guide to truth? Does that make sense? So we could say, well, the past success of induction, if inductive reasoning didn't work, then science would have never gotten where it was. We wouldn't have vaccines, we wouldn't have computers, right? So because induction has been so successful in the past, it will be successful in the future. Yeah, right? So it's got the same problem again. It's just the prediction from past successes to future successes. So that sounds good, but it just has the same problem. It doesn't answer Hume's question of what entitles us to infer future predictions or unobservable predictions from past or unobservable data. Any other ideas? Okay, you brought up Leibniz earlier, so just to clarify for your own interest, Leibniz thought the principle of sufficient reason could fix this type of stuff because he believed in God. So he says that God runs the world in such a way that everything has a sufficient reason, at least going back to God, right? So God is a sufficient reason ultimately for everything, and the buck stops there. The problem with that is that, well, if God is deciding that everything has a cause or sufficient reason, if he's all powerful, why can't he just stop doing that in the future, right? So even Leibniz's principle still won't work. Just to fill in that gap there. Okay, this is the last thing we'll cover for Hume. But I do want to offer one potential solution. And it's not so much a good theory about how this stuff works, as it is kind of just like a defensive move, where I say, well, wait, we can still believe that this stuff works even if we don't have a theory, right? Or we don't understand exactly how. Does that make sense? So there is this theory, right, called foundationalism. And foundationalism is a theory about how our belief structures are built. Our belief structures are, man, misspelling belief. On this theory, our belief structures are actually all built upon foundations. So let's say we have belief 1, belief 2, belief 3. We normally in our everyday lives believe things on the basis of some sort of evidence or experience, right? So these beliefs are themselves, let's say, they're inferred from other beliefs. Maybe belief 1 and belief 2 are actually inferred from, belief 4. So we're building a belief system on the basis of other beliefs. And then let's say belief 3 is built from belief 5, right? Okay. The question is are any of us like infinite? Do you think you could believe an infinite number of things? Weird question, right? Like, do you think your mind is capable of basically all at once believing an infinite number of beliefs?
All at once.
Yeah. Like, you think that your mind and your brain are finite, right? So you can't just, basically, think about this. If I believed one thing on the basis of evidence, then wouldn't I have to believe another thing that gives me this belief? And then I'd have to believe something else that got me that one, and I have to go on forever infinitely, right? Well, the way you stop that is you just say, at a certain point, you hit the foundation, the bedrock, and you can't go any further. And I think that's plausible just because I think we clearly don't have infinite beliefs. I will always hit some sort of stopping point in my belief system, my worldview. So, foundationalism essentially says that our belief system is a complicated tree growing up from some roots. And these roots are called the foundational beliefs. And these foundational beliefs, they're not believed or inferred from other evidence. They are just things that we believe without having any evidence to believe them. I think at some point we have to say that, or it would just go on infinitely forever, right? Okay, so what's an example of maybe like a foundational belief?
Gravity?
Gravity?
Maybe.
No, actually it's not.
No.
It seems like it because our culture is so post-Enlightenment scientific that we just take gravity for granted. But actually ancient peoples didn't, I think it was Aristotle actually, didn't see, so how gravity works is that the earth is pulling on us, right? Aristotle actually thought that we were naturally moving downwards, like we were the things moving, right? So in that sense, gravity is actually not properly basic. We've just really internalized modern scientific progress, right? What's a foundational belief that we might have? Something that you don't believe based on sense experience, or that you don't believe based on evidence, or you don't have any other arguments for, but that you think you know is true. It's hard to come up with them, right? Because sometimes they're so obvious. Okay, what about this? It's not the case that P is true and not P is true at the same time, which is called the law of non-contradiction, LNC. So you can't have contradiction be true at the same time, right? Does that make sense? It can never be true that I am Pierce and I am not Pierce at the same time. Where do you learn that from? Yeah. You don't get it from looking around the world. It's like, oh yeah, I just looked under this rock and science just discovered the law of non-contradiction, right? You know it on some intuitive level. You know it just by looking at it, just by thinking about it, it seems self-evident, right? Self-evidently true. Or it could be what Alvin Plantinga, a philosopher, calls properly basic. It's something that you don't need evidence for this to be true. You just need to think about it and look at it, and you'll know that that is true. Make sense? Okay. Well, here's another one. What if I gave you this formula? P then Q, P, conclusion, therefore Q. Good or bad argument form? Raise your hand if you think it's good. If it's a cat, then it's a mammal. It's a cat, therefore it's a mammal. Is that a good argument form? So cat, then mammal. Are all cats mammals? It's a cat, so what must it be?
A mammal.
Right. That's one example. I can give you 10 other examples that I have, right? But how do we know that this format is good? That this is a good, reliable way of arguing? How do you know that this is good and this is bad? If it's a cat, then it's a mammal. It's a mammal, therefore it's a cat. Is that good? No, because it could be a dog, could be me, could be you, right? So how do we know that that's a good way of arguing and that's a bad way of arguing?
Well, I would base it off like if we use the like cat one just like based off what you experience, like you see other mammals that aren't cats, so you like know that can't be true, but that's based off of experience.
Right, but so, okay, so you can test it with an experience, right? But that's just one example of this argument form. So how about you test it and you find, well, that's good there. It's also good if I say it's raining, or I should say it's pouring, then it's raining, it's pouring, therefore it's raining, right? Now, how do you know, though, that this is always good? Because when you look at this, and you just go through examples, you're learning them from a small set of examples, and you're saying, this must always be good. What's that sound like?
An inference.
An inference, a probabilistic inference almost. It's from a finite set of data to the entire set of data. Anything of this format will be a good argument in terms of its form. So you don't know this from experience. You know this on some intuitive level. That's the idea, right? It's just self-evident that that's good way of arguing, that's a bad way of arguing. All right, can anybody actually explain to me why this is good and why this is bad? And this is a deductive argument, right? Anybody able to explain to me why this is good, why this is bad? So Hume's problem of induction applies to deduction too. Because remember what the problem of induction was. How do we explain why inductive arguments make sense and are good? Well, it seems like we just intuitively grasp them, but Hume is worried that if we can't explain it, then it's all kind of on rocky, shaky foundations. Well, but it's the same thing for deduction, and Hume accepts deduction.
Well, I think in Hume's, I think the reason why he can accept deduction is because as an empiricist, his thinking is we gain knowledge through experience. So with, like, in that type of example, like he said, we could test it through an experience. So it was like inferences that could be solidified through like our senses, but with like inductions and like just like of probability and not necessity, there's like it's not as reliable.
But think about there's two things. First, how does going from, let's say, a finite, I'm running out of room, finite number of examples to all possible examples. How does that work? Because you're going to go through, maybe you go through 1 million of these type of examples of inference, right? Cat is a mammal, cat's a mammal. You're still going to end up with, you're somehow going from just what you've observed to anything possible that you haven't observed. So the same problem comes up, right? So if the point is, if Hume wants to say that deduction, that premises that guarantee a conclusion are somehow more stable or on better footing than induction, I think it's just, I don't want to say hypocritical, but Hume's problem applies to everything that we don't know through experience. So the solution I am suggesting is that we have these foundational beliefs. We just know, we have some sort of innate capability to know that this is a good way of arguing, this is a bad way of arguing. Similarly, and I can't pronounce things, similarly, we just know that if 99 out of 100 cases let's just say 99 out of 100 balls are red, we just know that it's reasonable to conclude that the next ball will be red, or will likely be red, right? Well, we can look at examples, and most times this type of reasoning will be right. It's the same sort of thing. It seems to me that we know how to use probability in the same way we know how to use deduction, through this sort of philosophical intuition. And it doesn't have to mean, oh, we all are born with these beliefs in our head. It could mean we are all born with an innate capability to recognize truths like this, right? So you can still kind of be an empiricist and believe in foundationalism, right? It's just kind of a more nuanced empiricism. Okay, so the idea is all of our beliefs rest on foundational beliefs. These are not supported by evidence. They are supported on the basis of something like, it's just obvious that these are true. We build all of our beliefs from those foundational beliefs. I think that the law of non-contradiction, that deductive patterns of reasoning, and that inductive patterns of reasoning are all foundational. Well, that doesn't mean I can tell you how they work necessarily, but I am telling you a story about how we probably don't really have to worry about it that much. It's an interesting question how these things work. And so you take a logic class and learn how to use deductive reasoning. And then after that, you might go to graduate school and study the nature of deductive or inductive reasoning. But I think it's obvious, even though it's not guaranteed, it's obvious that probability arguments like this are good, right? And if we want to doubt these type of probability arguments, we also have to doubt everything else, including deductive arguments, where there's a guarantee. So that's I think the best we can do with Hume's probability induction. Solve it like that, essentially. Does that make sense? Okay. Any questions or comments? All right.
How do you think foundationalism would fit in with like Descartes' idea of how we like actually experience things and what things actually are?
So Descartes is actually the first person to come up with the modern version of this, yeah. So Descartes is a foundationalist. He's a father of foundationalism. Now, he was a rationalist. He thought, which you've got empiricism, which is all knowledge comes from sense experience. And you've got naive rationalism, which says that all knowledge comes from, or the foundation of all knowledge is like these God-given or innate beliefs that we have. So he thought we literally were born knowing certain things. I don't think that's true. I think I'm actually myself more of a, if you know John Locke, he did a lot of stuff in political philosophy, but his best stuff, in my opinion, is not politics, it's this. He took Descartes and basically made it more empiricist and said, it's not that we have beliefs we're born with or that God gives us magically in our soul. It's that we have different programmed capabilities through evolution. And Locke was a Christian. He thought through the evolutionary process, God has given us certain kind of like programs in our brain and in our mind, that these programs can detect and pick up on these types of things and use them well, even if it can't explain it. So maybe the foundations aren't guaranteed, but there is some sort of inbuilt capability to do this type of thing, to know these truths. Yeah, does that make sense? Descartes literally believes there's a bunch of beliefs that because they're, they're sufficiently clear in the light of natural reason, what that means is they're self-evidently true. We know them for certain that they're true. Like, if I think, therefore I am. That's his great foundation that he builds upon, right? Okay. questions or anything? Okay, I think that's the best we can do. This is basically exactly what that Peter Lipton article goes over. I just explained it, all the solutions and steps in a little bit more common language. So read that Lipton article and just kind of try to relate it in your head back to what we've covered in class. Other than that, I'm going to extend the test deadline to this Sunday because a bunch of people are stressed out about it. So I'm going to give us more time to finish the test. Some students are saying it's taking them like 2 to 4 hours. Have you taken it?
Yeah, it took me like maybe an hour and a half at
Okay.
the most.
Yeah. I'm wondering if they're just overthinking it.
Probably.
But maybe, I mean, it is longer, so give yourself lots of time on the test. And yeah, I'll extend it, if you guys haven't taken it, I'll extend it till Sunday night. Thursday, I'm gonna show up. I'm gonna be here to answer questions and basically have office hours in the classroom. But you don't have to come to class Thursday. We've covered everything with Hume already. But if you wanna come, if you wanna shoot the shit about philosophy or about this, we'll work on some stuff for the test and homework, come on in and we'll do that, but you don't have to come to class Thursday again. We can use that time to do the test or whatever you want to do. Make sense? Any questions, comments, concerns? Okay, we're good to go then. Thank you three for coming to class today.
Thank you for coming too.
Yeah. Yeah, I don't really think the walkout stuff applies to our class because I already pretty much do all of this stuff. So.